Okay, so now that we're still in lesson 2.2, we are going to think about the three ways to describe what happens when you mix one solution with another and a reaction happens, meaning a precipitate forms. In the last video, we talked about molecular reactions. Today, we're going to talk about how to describe it by writing the complete ionic and the net ionic reaction. So, in the last video, we looked at this problem and we ended up writing this reaction, the complete molecular reaction or double replacement reaction, showing what happens when you mix barium chloride with potassium sulfate. And a reaction did happen because we discovered that we made a precipitate. The barium sulfate is a solid, which is a precipitate. So a reaction happened here. This is a molecular reaction. What we're going to write now is the complete ionic reaction that describes this. So to write the complete ionic reaction for this, you would show everything as being an ion, because remember this is dissolved. That's what this aqueous means. So if this is dissolved, that means that in this solution you have a barium ion, that's what the purple thing is, and for every barium ion you have two chlorides. The green things are chlorides. That's what this is supposed to be, chloride. This is a C. So for every one barium that you have two chlorides. And they're separate, and imagine them being surrounded by water molecules. They've been dissolved. So that's what this aqueous means. Similarly, here the potassium ions are separate from the sulfate ions. Let's write a complete ionic reaction to show how everything is dissolved. We would have barium, we write the charge, we say that it's aqueous. We have two chlorines here, so we have two chloride ions. They are dissolved, so they are aqueous. Plus, we have two potassiums here, so we have two potassium ions with a +1 charge each. They are aqueous. We have one sulfate ion here, so sulfate, 2-, that's aqueous. Now I don't think I have this on your notes, so you're just watching right now. Then you'd have the arrow. I ran out of room, so that's why I'm bringing it down here. And on the product side, this right here that I'm circling with the red light, this is not aqueous, this is a solid. So we would write this as barium sulfate together, it's one thing, with the S showing that's a solid. But this that I'm circling in red now, this is dissolved, this is aqueous. And here we have two potassium chlorides. So that means we have two potassium ions dissolved, and they're aqueous, and we have two chloride ions. So we've written, this is called the complete ionic equation because it shows all the ions. It shows the ions here that are dissolved at the end and how they were dissolved at the beginning. And it shows how these were dissolved at the beginning, but they came together to form a solid. So you have everything, even the things that are not technically participating. We're going to do another example. So here we have, and we're writing the net ionic equation for the precipitate reaction that occurs when aqueous solutions, these are aqueous, of calcium chloride and sodium carbonate are mixed. So I've written my two reactants. Now I have to decide which one forms a precipitate. I can do the double replacement and switch around and show the potential two things that could be precipitates. So let's do that. So I've written my potential precipitates here, calcium with the carbonate, sodium with the chloride. I have my products are written correctly, one calcium for each carbonate, because this is +2, this is -2, one sodium for one chlorine, +1, -1. I have to check to see if my reaction is balanced. It's not, so I'm going to balance it. 2 here, gives me 2 sodiums, 2 chlorides. I put 2 here. Something is going to go wrong here. I figured it out. I wrote this wrong. There should be a 2 down here. So let me erase this. Oh, it won't let me erase. Let me cross it out. So now this is balanced. I had written the sodium carbonate wrong, but I put in my subscript here because for every carbonate you need 2 positive 1 sodiums. Now I needed to figure out which one is going to be the solid. Will both be solids? Will none be solids? So I'm going to look at my solubility rules, which I have candidly put down here. I'm first going to check out calcium carbonate. So I'm looking for either calcium or carbonate, and I see carbonate here. Carbonate is insoluble. Here are the exceptions, unless it's with ammonium or the alkali metal cations. The alkali metals are group 1. This is group 2. So this is going to be insoluble because this exception does not apply. So if it's insoluble, that means it's a solid. Insoluble means is not soluble, does not dissolve. We'll check out the sodium chloride just to see. And sodium chloride, we're looking for sodium or chlorine. I see chlorine here. And chlorine is always soluble unless it's with these 3 things: silver, mercury, or lead. This sodium is not silver, mercury, or lead. So this is soluble, meaning it dissolves, meaning this is aqueous. Okay. Oh wait, I have to rewrite mine. Okay, so this is our molecular equation because it shows all of our compounds as molecules or formulas. Now we're going to write the complete ionic, which is what we wrote before. I'm going to break each of these things into their ions if they're dissolved. I won't break this one up because this is a solid. So you try to do it, I'm going to do it. So if you paused it and tried to write the reactants, this is what you should have. A calcium ion that is aqueous, 2 chloride ions that are aqueous. That 2 is because this 2 is here, and when this splits up, makes 2 chloride ions. You should have 2 sodium ions, and you should be writing the charge for each ion. This 2 comes from this 2. You should have 1 carbonate ion. Those are your reactants. Now we're out of room. I'm going to do my arrow down here just to get more room. My products, this is a solid, so this does not get broken into ions. It exists as a solid now. Calcium carbonate. The bonds between the calcium and the ion and the carbonate are stronger than the bonds between the water molecules in each of these. So this exists as a solid. Then I'm going to have, this is aqueous, so 2 sodium ions here. I label it as aqueous. And 2 chloride ions. You need the 2 so that it's balanced overall. Now, what I've just written is the complete ionic reaction. I wanted to show you how to write the net ionic reaction. To write the complete, first you write the complete. The net ionic reaction includes only the ions that reacted to form a precipitate. So I'm going to look at this. The calcium sulfate was my precipitate. So I need to include on my reactant side the calcium, did I say calcium sulfate? And the carbonate. This chloride is dissolved at the beginning and it's dissolved at the end. That means we call that a spectator ion because it's just around to watch. So I'm not going to include this in my net reaction. This sodium also is dissolved at the beginning and dissolved at the end. It does not react. Spectator ions do not react. Oh, where's the pen? Spectator ions do not react. They're just watching. So this I'm not going to put in my net ionic reaction. So let me squish this up, and we're going to write the net ionic reaction to include the calcium and the carbonate as reactants and what that makes. So I circled what I'm including. So the net ionic reaction will be Ca2 plus aqueous plus the carbonate 2 minus aqueous, producing the calcium carbonate solid. This is the net ionic reaction. And we'll talk about this more in class.